This video is a combination of multiple videos taken from the Level 301 and Level 302 Velocity Programming courses in Atlona Academy. We have put them together with chapters to help you get an understanding of how to create your own drivers. For more information on velocity training, check out Atlona Academy. Velocity has created a lot of drivers, and we encourage you to modify or even create your own. In this course, we're going to show you how to learn an infrared remote and how to set it up quickly in your device driver. However, you won't have this information, so we're going to walk you through it and show you how to do it. Just watch and learn. When we are ready, in the resources, you will upload this driver so you can associate it to the media player. If you'd like to learn more about creating and implementing more complex drivers, like DSP drivers, you can go to our website and you can look up the integration of the DSP. When we talk about building a driver, we basically need the API for the RS-232 and TCP/IP codes. These are the commands that the manufacturer gives us to allow for that third-party control. But when we're learning an actual remote, we need to grab the hexadecimal values that are passed through the air. What you need to do first is associate a VCC that you're wanting to connect to the device, and we're going to select the IR to activate the ability to learn the remote. To connect to a VCC and make sure it's set to the control type, you need to go to the web server for the VCC. You don't have one attached, but I want to show you what you would need to do to make sure your VCC is properly set up when you get to site. Now we can connect our VCC and our technology. In order for me to do this learning of the IR, I have to use a connected device. Again, just watch, and when we are ready, you will be able to upload the completed file just like you would if you had to learn a device back at the shop and bring to the site. Once you know you have the VCC attached, you can select Device Drivers under the Control tab, then select the plus sign to create a new driver. We're going to fill in the form. I'm going to fill in the name, and I'm going to add AA so that we can locate this when we enter it into our database. You can pick a canned category that will help you with some of the standard commands. We're going to select Miscellaneous. In order for our device to show up as a source in the selection on the template, we need to select it as a video source. If I were connecting to a display, I would select the display projector. Under the other tabs, we're going to select the IR as the only control. And there's no video in, but there is a video out to the source. We're going to go ahead and we're going to add some images here so that I can locate it in my database. If I select the save, it will take me out of the device driver. So you may want to learn all of the commands in one sitting. Now let's look at the commands. I'm going to reduce the number of commands to just the few we're using. In order to learn the device driver, you need to be connected to the VCC. Then select the Learn link. Point the remote to the velocity adapter and hit the button. There. You'll see our first command. You'll need to do these same steps for all the commands within your velocity driver. I went ahead and finished the driver. You can now download it from the additional references. We want to now upload the driver by hitting the plus sign and import. Now let's add the new media player to our room. We're going to connect it to our MS42 in place of the one we added earlier. We're also going to need to connect the VCC, and you can see I can choose which of the infrared buds I want to use. Atlona has a lot of drivers, and I've shown you how to create your own driver. But what if you have a file and you're just missing a feature? Our LG display allows for multi-screen, so we're going to edit the existing LG RS-232 driver. Under Device Drivers, search for the LG display. Now you can look or copy it. In order to edit it, you will need a copy. Let's go ahead and edit the name so that we know this is our driver. Let's add underscore AA to the name so we can find it later. We can see it's using the display category and the display projector, so that when it comes up in the template, it's set as a display. Because this is my driver, I know that I'm only using a few commands, so let's remove a bunch of these and only have the power, the volume, with the mute, HDMI 1 and HDMI 2. Go ahead and pause the video and remove the commands that we don't want. Now let's look at the RS-232 code for my display. You can see how the power on and power off are set up. The set ID can be found in the menu of the display, but by default it's 01. The command we're missing is under the input. We want to add the multi-screen command of E2. Now in the next video, we are going to add this display and assign it to new buttons to our touch panel. It is encouraged for you as the programmer to create your own drivers if possible. You have the devices, and we will show you how to create them. We are going to start by looking at creating or modifying a driver that uses WebSocket. To do this, we are going to look at the API for the Wave 101, which uses WebSocket. To figure out the commands, it's best to connect directly to the unit, and if possible, use software to connect to the device to test your commands. For WebSockets, there is a free extension for Chrome called WebSocket Test Client. To connect to the Wave 101, it's the IP address and /WS. We are going to connect to the Wave in our rack to show you what this looks like. Next, let's look at a command that you might want to add to the touch panel. As we already set up, we have a web view that gives you the instructor URL and allows the user to moderate the queue for the Wave. But what if the queue was not enabled on the settings of the device? Let's add this to a button to enable this command that is found under the settings page. This command is the instructor enable. We are going to open the API of the Wave and copy and paste the example command and place it into the request box. You can see we get the response, and the instructor queue is now enabled, and it shows up on the instructor page. Now, let's change the true at the end of the command to false. It goes away on the panel and back on the device. It is now disabled. This gives us the commands we want to add to our Wave driver. Let's open the device drivers and search for the Wave. Now let's copy the device and search again. In order to make certain you have the right device, let's edit it and rename it. We will add the initials of AA for Atlona Academy. Select the Commands tab, and let's add two commands, one for the queue to be on and the other for the queue to be off. I am going to grab the code that I used in the WebSocket test and add it to the command syntax. Let's add it to the second command and change the true to false as we did in the test client. Now we will save the driver. Let's talk about making a driver. We are going to look at how to make a driver that uses the DSP control, which is the slider and mute functions built into Velocity. As with the other drivers, you will need to be connected to the physical device. We have a PS62 in our rack, so we are going to create a driver for the 4 volume controls in the PS62. Open the API for the PS62. It can be found here under the resources on the product page for the Omega PS62. We are going to look at the 4 audio outputs. You can see the control on the web server here. As we create this driver, you should be thinking of other products that use sliders, levels, faders, or mutes. This could be a lighting or microphone control, not just a speaker output. In the API, we see the vout command and that it is used for the 4 master volumes. Back in Velocity and under Control, select the device drivers. To create a new one, select the orange plus sign, then select Add via Form. Name the driver something that you will be able to find, but also that you might be able to use again. We will call this one Master Volume PS62. And let's add the initials so I can locate all of my own drivers in my databases. Atlona is the manufacturer, and for this driver, we don't need a long name, but we will put in the full model number, Atlona PS62. The category will automatically add certain commands to help you, but we are going to set it as audio and the subcategory Atlona device. Because this is a custom driver for levels and mutes, we are going to not enable these two buttons because these put the driver into the templates as displays or sources. Before we can save this driver, we have to say how we are going to be connecting to the device. For this device, we're going to use Telnet. Save the device so we don't lose it. Let's locate it again and edit it to add the commands. We could add a picture or other inputs and outputs for audio and video if this was a larger driver. But for this, we are just looking for the commands to be part of the control links or the drop-down menu for the device on the custom UI. Looking at the API for this device, we have for the mute discrete on-off and for both the levels and the mutes. We are going to remove the existing commands by selecting delete. Now let's add the first command. First will be the gain and the next will be the mute. Now, I am going to connect my device to a free software called Hercules. We are going to connect using TCP client, the IP of the PS62, and add the Telnet port of 23. To see what the commands are, we are going to move the volume for analog 1 up and down and the analog 2. Check out the mute command. Back in our driver, we are going to add the command for the first slider. The command is vout, and then it is a channel, and then a value. To add the channel number, we are going to use the %C, and for the variable value, we are going to use %V. For the mute commands, we will use the command voutmute. This is case sensitive, so note that the M is capitalized. Next, like the gain, we need to add a channel, %C, and a variable value, %V. Now, let's go to the next tab, DSP. This is built into Velocity to allow you to connect the control links for the sliders directly to this command and the DSP widget to the mute. Add a new DSP control. It automatically adds both the mute and the gain, and it gives you some pre-filled information. First, we want to select the command from the list we just put in, and we want to add the channel for the 4 different master sources. We are going to just remove the Please Fix Me and leave the one for the HD base T for the gain and the mute. This will add the number here. Now this control name is what will show up in the control links, so I'm going to add some information like HD base T and HDMI to make it easier to assign. The variables for the off and on are right here, and let's remember that they are case sensitive, all lowercase. Next, we will select the gain and replace the number 1 and change the name to add the HD base T. For the gain, let's check on the device what is the lowest level, minus 90 dB, and of course, the highest level is 10 dB. Because we are going to send this command and increment 1 dB at a time, we wanted to update the command when you release the button. So let's select the On Release toggle. Now let's add another, and Velocity assumes it's the next channel, and even fills in the variables. Let's remove the Please Fix for the second channel and add HDMI to the second output channel. Finally, let's do this for the two analog channels, 3 and 4. Let's add feedback. Under the variables, we will add a new variable. We are going to call it gain 1, and we want to use two-way parsing. It pre-fills the characters that possibly come before it, and if you see this information returning from the device system, then grab what is after the %sign. We know the characters for this first output is vout1. Now let's turn on the show actions, and it will allow us to connect with the DSP we just created, gain 1 HDBT. Do the same two-way feedback with the second, third, and fourth gain outputs. Now let's look at the mute. What we want to do is make sure if there is a change in the web server or front of the unit that the change is indicated on the touch panel. Let's name it mute 1 on. The command we are looking for is vout mute 1 on. For this DSP feedback, we want to look for the assigned value. This is because Velocity is tracking the DSP feedback as a 1 or a 0, but the PS62 sends an on or off. So we are going to take the PS62 feedback and write it as a 1 or 0 so that the DSP mute understands it. Now, let's make sure to connect the broadcast DSP control for mute 1. Let's copy the on and rename it, mute 1 off. The substitution key can be the same because what Velocity is looking for is an exact match, so change the on to off, all lowercase. Remember to connect the broadcast DSP control for the off as well. To get real two-way feedback for all four mutes, both on and off, we are going to add them quickly by just using the copy command. It puts the new command in the last position at the bottom. Make sure to save your driver. Back in the room, let's add this new device. For our system here, we will add the IP address so that you can see what happens with the connected system. Let's open the custom UI and go to the Tech page. Add a horizontal slider towards the top of the page. This will be the HD base T gain, and then add the DSP mute widget. On the slider, we will open the Control Links tab and select this PS62 device and the control channel 1. For the mute, we will grab the PS62 and the first channel and change the color like we did with the gain. We can put in the other three by copying the sliders using the right-click Select Copy. Then right-click on the page and select Paste Control. This copies the previous control links, so let's change the control channel and then the label. Let's do the same with the mute for channel 2. Add the third and fourth channels. Now let's test. Let's open the browser window and the web server for the PS62. The key to this driver is that if we change the volume, for example on the web server, it will give us that feedback on the panel.